Hey y'all, we are Memphis Community University and we are back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today we're going to be doing our third video on U-Substitutions. So this is the video that follows our indefinite U-Sub video and our definite U-Sub video. Today we're going to be taking the integral of general functions with U-Subs. So instead of having things like sine of x or e to the x or fractions where we perform U-Subs in order to take the antiderivative, to take the antiderivative of these functions, they're going to include things like the integral of f prime or the integral of g double prime, where we don't know what f is, but these integrals will actually be easier because all it is the integral of f prime is just f, the antiderivative of g double prime is g prime, for example. So these are actually going to be a little bit easier. They are asked in a bit of a weird way. They usually appear on the multiple choice section of the AP exam and maybe college calculus exams. So we're going to examine those. But before that, keep in mind that this does follow our indefinite U-Sub video and our definite U-Sub video, and this is going to involve the same steps, choosing our U based on various hints, doing the U-Sub process, U, du, and then changing all of our x's to u's, including the numbers like we did in that definite U-Sub video. So we highly encourage you to watch those two videos before this one, but let's get started. Before we talk about integrals of f and g's, I just wanted to talk about one question that appears in the multiple choice of the AP exam. It's actually an easier question. Basically what they're going to say is start performing a U-Sub, but eventually stop. And one way that it's also easier is that they actually tell you what the U should be. They say, let U be this, now try to perform this integral. And remember, choosing the U is sometimes the hardest part of an U-Sub. So an example question would be letting U be this function. So letting U be x cubed plus 1. Try to convert this integral into another integral. So we're going to try to convert this integral right here. It's going to be sine of x cubed plus 1 times x squared times dx. Then we're going to have numbers 1 and 3. So this integral, what we're going to do is we're going to perform the U-Sub process with the U that they graciously gave us. Thank you very much. We are going to take it and we're going to change this to an integral with U's, but we're actually not going to take the antiderivative because as you'll see, or as they pose the questions, the answer choices will be these integrals themselves. So what we're going to do is we're just going to take this integral and convert it to another integral, and they're just going to say, that's good enough for now, you can stop the question. So again, this is a rare multiple choice question that does appear, but it's actually pretty easy. But it's a nice way to review U-Sub, so let's get started. So U is equal to x cubed plus 1, x cubed plus 1. So we're doing the U-Sub process. Again, they gave me the U, so I don't have to think about choosing the U. So I'm going to let this take the derivative immediately with the power of 3x squared times dx. Then I'm going to change my integral in terms of x's into in terms of u's, and that's basically what they want me to do. So it's going to be the integral of sine of, well, it's going to be, looks like it's going to be u in the parentheses here. Then you look for your remaining x's. Looks like we have our remaining x's. It's x squared times dx. So x squared times dx. Let's isolate it. I like this step. Remember that if you're doing this correctly, the remaining x's after the first line will be exactly this. Instead of writing x squared times dx, we're going to replace it with du over 3. So nothing new here. I just wanted to point out that these are questions that they asked. I'm going to write du and I'm going to put the 1/3 in the front just like normal. And then finally, from our definite U-Sub video questions, you'll know that you need to change the numbers as well. So when x is equal to 1, what you do is you plug it into the function. So it's going to be 1 cubed plus 1. That's going to be 2, so it's going to be 2 on the bottom now. And then finally, when x is equal to 3, looks like my new u is going to be 3 times cubed, there's 27, 28. And actually, we're going to stop here. Again, there's going to be some questions where the answer choices are going to look like this. So wrong answer choices could be, for example, if they left out the 1/3, or if they left out the if they didn't change the numbers, so they kept it as 3 and 1. So again, these questions aren't too bad. Usually people can do them. It's really just doing the U-Sub to a halfway process, but I wanted to point them out just in case that you might see them and you were a little bit confused about them. They are easier than regular U-Subs, of course, because you only have to go halfway, but sometimes they're a little trickier, so let's do one more. This is not really the emphasis of the video, but I do want to point them out. So let's say we're letting U be x plus 2, and what we're going to do is we're going to try to convert this integral in the same fashion so that it's only in terms of dx's, or in terms of x's, u's, not du's. So we're changing the x's to u's. Don't know what I'm saying anymore. Let's let x be on the bottom 4 and 7. So this is our new guy. So we're just, again, what's nice is that they gave us a u. This is actually a harder integral to do. This is a college level integral in my opinion. So let's just get started. U is equal to x plus 2. Derivative, if you want, you can write 1 times dx, but I'm just going to write dx. So this one is a little bit trickier than normal integrals because once we replace the u, let's replace the u real quick. We're going to replace the bottom with u. And then the top, it looks like I have a dx. I can replace that with du. But unlike previous questions, unlike all the other questions that we have done so far, these first two lines weren't sufficient enough to change all the x's to u's. I have this remaining x and I have to replace it with something. So this is what I call a double u substitution. Nice question to practice. What you do is you look at your original line, and because of the way that this question is asked, we're able to isolate just x in terms of u. So it's going to be x is equal to u minus 2. So we have to use this line twice. That's why I call it a double u sub. So it's at u minus 2. So that's going to be our integral. Then the easy part is to change the numbers. X is equal to 4. X is equal to 7. So again, you just plug it into this. So it looks like it's going to be 6 and 9 because, let me write that with u's. U is 6. U is equal to 9 because we're just adding 2 to both of these numbers. So now it's going to be 6 and 9. And then again, this could be the answer choice. And these questions, when they give you the u and they say convert this x integral into a integral, all 4 of the answer choices are going to have u's. And then there's going to be just variations of the integral to make them wrong. So for example, one answer choice that would be wrong is if they had 4 and 7 still remaining on this integral. But I want to actually do this integral. Let's actually just finish this question because it's a nice integral to see. So again, this integral right here, it would be the answer, but we're going to move forward because we are sort of pioneers in this. Let's just do one last thing. Let's actually do this integral. Why did we do a u sub in order to convert this? This is actually because we can split the numerator, but we can't split the denominator. So this is a good practice of splitting the numerator. Notice that now the addition or the subtraction is in the numerator. So that's why we're doing this, because we can split this guy. We weren't able to split it as a denominator. So this is going to be the integral from 6 to 9, u over u minus 2 over u du. And then we're going to do this integral. We're going to convert this to be 1, simplify it a little bit, and now we're ready to do the integral. What's the integral of just 1? Well, that's just u. Hopefully my marker isn't dying. And then what's the integral of minus 2 over u? That's not the power rule, that's ln, so it's 2 ln of u. And then remember that when you're doing these definite u subs, you don't need to remember x's anymore. So when you plug in 9 and 6, looks like it's going to be 9 minus 2 ln of 9 minus 6 minus 2 ln 6. Then we have just doing a few number manipulations. 9 minus 6 is going to be 3 here. Minus 2 ln of 9 plus, so we have minus 2 ln of 9 plus the ln of 6, it looks like, because it's minus minus. There's a 2 in the front here because there's still a 2 here. I'm going to rewrite this because it's very, very messy. 3 minus 2 ln of 9 plus 2 ln of 6. I don't know if that's any neater, but remember that when you have subtraction, ln of 6 minus the ln of 9, that's actually division. So we can simplify this to be its final form, 3 plus 2 ln of 6 over 9, which is 2/3. So this is going to be our final answer. Again, if you wanted to, if you look at the practice of our Girls Teach Calculus video, it sort of imitates AP exam questions. The answer will be this, but the point of this integral is to try to split the denominator, which is not allowed, to split the numerator, which is allowed, using the u sub. But that's it for these sort of questions. I've probably spent too much time on these sort of questions. They're not going to be too bad. They don't appear very often. Let's actually do general u subs, which is the title of this video, involving integrals with f's and g's. So I'm going to erase this real quick. I'm going to erase this, and we are going to do what we've set out to do. So instead, usually these tables, these integrals are included in a table, especially on the AB portion of the exam, where they're just saying take a lot of derivative as integrals. So we're going to do that. F of x. Let's say we have these three numbers. Let's say we have 1, 5, and not 5 maybe. Let's just do 4 and 1, 4, and 16, I think is what we want here. Then we're going to put random numbers here. So this is going to be my table, and they're going to ask us to the integral of f prime of 4x dx from 1 to 4. So again, the point of this video is to practice as much as possible integrals that are not just in terms of sines, cosine, e's, and ln's, but in terms of just general functions f prime. But you'll see that it's a lot easier because when we do the antiderivative will also be a lot easier. When we plug in the numbers, it'll just be from the table, so that's also a lot easier. So let's do this integral. So again, just like a normal u sub, you let the u be the inside function. That's going to be u is equal to 4x. Then we're going to take the derivative. That line is going to be 4 times dx. Now it's time to change all the x's to u's. Let's do it one line at a time, just like normal. So we chose 4x as our u, so we can put it inside here. Then we have a dx. We need to sub in this dx. It's always going to be in the second line, or most of the time it's going to be in that second line. The previous one it wasn't. But most of the time, it's just right here, dx. So if you want, you can write dx is equal to du over 4. So we're going to replace this dx with du. You can write over 4, or you can just take it out like I like to do, 1/4. And then don't forget to change the numbers. Even if we have just f's and f primes, we're still going to change the numbers. So it's going to be x is equal to 1. U is equal to, well, when you plug it in, don't plug it into the function. Be careful. You plug it into the u value. So it's going to be 4. Because 1 times 4 is 4. And then when x is equal to 4, it looks like we have u is equal to 16. So now we have numbers on top of our integral, 4 and 16. Just like with our definite integrals, we're going to forget about x's for the rest of the question. So don't look at this. It wants to hide from you. You only are looking at the u integrals because we changed all of our x's to u's and also the numbers on the integral. All of our x numbers now to u numbers. We don't have to look at this anymore. So what's the integral of f prime of u? That's just f of u. Just like the antiderivative of velocity is position. That's one of the easiest antiderivatives by definition. So we have this 1/4. So it's going to be 1/4 f of u, and then we're going to plug in, again, we don't care about 1 and 4 anymore, we only care about these nice u numbers. So if you want, you can label it u of 14 and u of 16. So let's finish the question at the top here. This is definitely not the best way to do math, but we're going to go way to the top because I ran out of space here. It's going to be 1/4 f of 16 minus 1/4 f of 4. Then we're just going to read the table. So again, I think these questions are a little bit easier because when you don't have to deal with fractions too much, you don't have to find what the sine of pi over 3 or something like that is. You can just read the table. So what's f of 16? That's going to be 5. 1/4 times 5 minus 1/4. What's f of 4? That's 2. Let me see if I can write a 2 here. So it looks like our final answer is going to be 5/4 minus 2/4. That is 3/4. And that is the key. So what do people mess up? Well, they mess up a few things. First off, they don't change the numbers. So when they change they don't change the numbers, they plug in 1 and 4. So unfortunately, they use these function values. Another mistake is to not do the u sub at all, and they just think that antiderivative is f of 4x, for example, but you need that 1/4 in the front. So I like to do u subs here. Again, nothing too crazy. Still like before, just do the u sub process. Remember to change the numbers. Change all your x's to u's. Then take the antiderivative, but the antiderivative should be pretty easy. The integral of f prime is just f. And then finally plug in those 2 points, and be careful, plug in the u values and not the x values. So let's practice this again, because again, this could be on the free response question, and portions of the free response questions are weighted more than the multiple choice questions. Of course, we're trying to get every single question because we're the best. But we might as well focus on the ones that are weighted a little bit more. So I'm going to do this guy right here. Imagine we have this as so, this. So let's see, what do I want? I want an x here. I want some numbers. Let's put 1, 4, 6, and 7. Then let me write my integral that I want first so that I know what I'm doing. So it's going to be the f of x times f prime of x, I believe. So we will want numbers 1 and 4. And then we're going to mix all of these numbers up. So this will be 6, this will be 7, this will be 1 and 4, f of x. And we have 2 functions here. So we are going to have g of x as well. This will be 3, 7. Let's not put 7 because this was already 7 here. Let's put a 2 here. That's a good number. And let's do this as our table. So hopefully you can write this table down. And now we're going to do this integral. We're going to change this integral a little bit. We're going to make it slightly harder because we are always in for a challenge. We are always willing to accept the challenge. So it's going to be this thing minus the integral of 2x. And then let's see if we can squeeze a dx in here. We are good to go. So again, what you're going to be doing throughout this question is you're going to be using this table. But let's not ignore the table for now. Just like in the previous question, use the table at the very end when you have to evaluate stuff or when you have to plug in stuff. Let's just approach this integral. And while this integral might seem intimidating, we can still use the rules that we know. The first off is that this integral involves stuff with g's and stuff that are not in g's. So a good idea is to probably split this integral up. That's always a nice, lovely process because then we can do one harder integral and then we can do one simpler integral and we can break up the question. So that's what I'm going to do first. I'm going to write this as the integral of 1 4 g prime of f of x times f prime of x. Looks like I'm missing a parentheses. Then I'm going to write the minus times the integral of 2x 1 to 4 dx. So again, I'm changing this harder integral into two somewhat simpler integrals just to make my brain a little bit more manageable in terms of these questions. So let's do this one now. I'm going to do the integral that doesn't have f's and g's because all I have to do is just take the antiderivative. Just be wary that we're going to be doing these integrals quite differently. The table is going to tell us this integral. We can probably put a dx here. And then this one will be an antiderivative. So I've seen some of these integrals before where you do a portion with like area and then an antiderivative or a table and antiderivative. Just be wary that you can do integrals in different ways, certainly. So this integral right here isn't too bad because its antiderivative is just x squared. We have a minus in the front here, and then we're just going to plug in 1 and 4. So it looks like this one is going to be minus, plug in top minus bottom, just like the fundamental theorem of calculus tells me to do. And I never not listen to the fundamental theorem of calculus. So it's 4 squared minus 1. So it looks like it's 4 squared minus 1 squared. That's going to be minus 16 minus 1. So this is going to be minus 15. So what we do is we're going to find this integral, and then at the very end, we are going to subtract 15 because that's this portion of the question. So let's do this integral. This is going to be the u sub. So first, spend a few seconds trying to think, should my u be f of x? Should my u be g prime of x? Should my u be f prime of x? And I'm about to tell you the answer in 3, 2, 1. So I think that the u should be f of x. This follows the pattern of our u's. Our main u sub hint when you're choosing the u is to choose a function whose derivative is also in the question. So that's why u is equal to f of x is a great choice in my opinion because its derivative is right there. So let's just start the u sub process. If u is equal to f of x, that means that du is equal to f prime of x dx. So now let's start changing all these x's to u's. So when I write this integral, looks like I chose this u to be f of x so that I can have g prime of u. How lovely. And then I have remaining x's, but remember that the second line will always have the remaining x's, and it looks like it's exactly what I want. F prime times dx is exactly du. So I'm going to replace this with du. So it looks like our integral is becoming simpler. U subs for the win. How lovely. So we're going to do this integral right now. But remember, you have to change the numbers. If you don't change the numbers, unfortunately, you'll miss the question. So let's change these numbers real quick. When x is equal to 1, how do you change the number? Remember, you don't plug it into all of this stuff. You just plug it into your u choice because we're doing u numbers. So what's f of 1? Well, f of 1 from the table is 6. So it's going to be u is equal to 6. Then we're going to change the 4 number. So when we plug in 4, looks like when we plug in 4, you get 7. So u is equal to 7. So then the answer is 7 and 6. So now we're ready to take the antiderivative. Time for the fundamental theorem of calculus, my favorite part of life. So this integral is going to be g of u, and then we're going to plug in 7 and 6. So it's just going to be g of 7 minus g of 6. And now it's time to read the table. That's the best part. 8 minus 5, so be careful. The minus comes from the fundamental theorem of calculus. There was already a minus in the question. So it's going to be 8 minus negative 5. That's going to be 13. But don't forget that we have this minus 15 in the end. So it looks like our final answer, from the very beginning, we split up this integral. So our final answer is going to be this number minus 15, so it's going to be 13 minus 15, and that's going to be negative 2. And that's all it is. Again, a more intimidating question, but hopefully you see that we stick to our guns. We were able to do the questions as we followed our normal hints and our normal strategies. So one of our big strategies is always split up an integral if possible. We did this integral by just taking an antiderivative, and this integral was the u-sub. And when we chose our u, it made sense that we wanted to choose f of x because its derivative is also in the question. We changed our x's to u's, including the numbers. And then once we did that, the integral of g prime was pretty simple. It was just g, plug in top, plug in minus bottom, and then combine the answers in the end, and we were good to go. So again, even in these questions that might involve 5-10 minutes of fun math, if you consider this fun math, as long as you know your steps and know your strategies, even if the question's a bit weirder, you're going to prevail in the end, and that's always fun. So other than these charts, which appear more on the free response questions, let's do some hard multiple choice questions that involve f's and f primes and f of u's and things like that. So I'm going to try to do 2 questions in one because a lot of people get confused about these questions. Basically, it's sort of like our previous questions where they'll tell you an integral value and they want you to find another integral value without actually finding the original. So you don't take any antiderivatives in these questions. Let's try to do some. I'm going to have given this integral of f of 2x times dx, and let's say that this is 2 and 4. That's good enough for me. And let's say that this is a given, so this is going to be equal to 3. The question is going to ask, what is this integral? So this integral is going to be 4 to 8 of f of x dx. So this is going to be my first question. My second question is going to resemble this question pretty much. It's going to be given a certain integral, or we'll write it later. What we're going to try to do is find a second integral. So this is going to be the integral of f of x squared times x. We're going to go from 2 to 3. So given that this integral right here, I believe we want 4 and 9. So these numbers are pretty contrived when they set up these questions. So notice that in both of these questions, again, we're going to try to do them back to back so that we can sort of relate them with each other. But in this given, it looks like the harder integral is equal to 3. In this given, it looks like the harder integral is the one we want. But in both cases, we're going to use a given integral to find another integral. And what we're going to do is we're going to do the same thing no matter if the given one is the harder one or the given one is the easier one. What we're going to do is we're not going to look at what's given and what's wanted. We're going to start off in these questions with the U-subbable one. U-subbable is an adjective I, of course, created. Basically, it's the one where you can achieve a U-sub. You can do a U-sub because there's an inside function. So in this case, the U-subbable one is the harder one. It's always, notice that we can make a U-sub here because we can let U be 2x because 2x is an inside function. Same thing with this one. This is going to be the U-subbable one. This is the one we're going to perform a U-sub. And then once we perform the U-sub, what we're going to see is that this integral is intimately related with this integral is intimately related with this integral, and we're going to have a nice little equation, and we're just going to solve the equation. But let's start off with this one. So again, in this one, I'm going to start off with a given, and this one I'm going to start off with the want, because I always start off with a U-subbable one, not based off given or want. So I'm going to start off with this. It's going to be the integral of 2 to 4 f of 2x times dx. I'm going to try to do this integral. So keep in mind that this is a u-sub. What's the inside function? Shouldn't be too bad. This is just u is equal to 2x. du is equal to, well, just immediately take the derivative. It's going to be 2 times dx. So I'm ready to change this integral. Looks like this integral is going to be f of u, because we replaced the 2x with u. Then we have dx here. If you want, you can always do our nice little step of isolating all the x's that you have left. So in this case, it's going to be du over 2. So we're going to write du over 2 instead of dx, but we're going to take out our constant just like normal, 1/2. And then, of course, we have to change the numbers. So when x is equal to 2, we need to change to a new u number. What we do is we're going to multiply by 2. U is equal to 4. So I'm just doing the u sub just like I normally do with a 4. When I have x is equal to 4, I'm going to plug 4 into this function as well. That's going to give me u is equal to 8. Looking that these are 4 and 8, so I'm probably doing the question correctly. So notice I have done the u sub. I've changed this integral in terms of a u integral. So if you look at what we want and what we would change our integral to, it's very, very similar. It's f of something d something. So this is called the constant of integration, and it doesn't matter. So the integral of f of u du is the same thing as the integral of f of t dt, which is the same thing as the integral of f smiley face d smiley face. Whatever your variable is, it's going to be the same. So basically what we did is we converted this x integral into a u integral, but the u integral happened to be exactly the one we wanted to times 1/2. So how do we solve this question? Remember that this original integral is equal to 3. So we can write equal to 3, which means that this integral, which is the thing we want to find, times 1/2 is equal to 3. So we are good to go. What we're going to do is we're going to just solve this easy equation. 3 times equals 1/2 times the thing we want to find, which we're going to just label x, is this integral right here. How do you solve this? Of course, you just bring the 2 over. So x is equal to 6. And that's the answer. This entire integral is equal to 6. So again, how did I do that? Well, I first started off with the u-subbable question. I performed the u-sub in the way that I normally do, changing u, right du, substituting in, also changing the numbers. And what I noticed is that after the integral, I got 1/2 the integral of the one I want to find, because the constant of variables doesn't matter as long as the numbers are the same. And we have 8, 8, 4, 4, f, and f. But I don't want 1/2 times the integral I want just the integral I want. But the original integral is equal to 3, and when I performed the u-sub, I didn't change anything. That's the point of the u-sub, so that you can just change a harder integral into an easier integral, but the integral value stays the same. So this integral right here becomes 1/2 this new integral, and what I want to solve is for this new integral, so I just brought the 2 over, 2 times 3, and that gave me the answer 6. So again, I performed the u-sub, converted my x integral into a u integral. That's happened to be the one I want. And then I have the simple equation, 3 equals 1/2 times the integral I want. So the integral I want is equal to 6. Let's see how it's slightly different when it's in this format. When the u-subbable one, the harder question is not the given, but it's the what. So in this case, we're going to again start off with the u-subbable one, because that's the one you can perform a u-sub on. So I'm going to do that real quick. I'm going to start the u-sub. How exciting. Let's see if I can write a u here. Why is my pen not working? U is equal to x squared. Let's get going. Why did I choose x squared as my u? Well, it's the inside function. Also, its derivative is in the question. Let's put a dx here to make things a little bit more proper. So then we do du. That's the derivative. 2 times x times dx. Looks like we're doing the question correct, because those are still in the integral. So let's change this integral right here into now a u integral. It's going to be integral of f of u, because that's why we chose x squared as our u. If we're doing this correctly, this x dx should be in the second line, and look right now, it is x times dx. We want to isolate it, so if you want, you can certainly write this step out, du over 2. We're going to replace the x dx with du over 2, but of course, I'm not going to write du over 2. I'm going to write it as 1/2 here. Finally, this integral, we need to change the numbers. So when x is equal to 2, we're going to plug it into here. 2 squared is 4. Look, there's a 4, so it looks like we're doing this correctly. Again, these questions are contrived where these numbers match perfectly. When x is equal to 3, 3 squared is 9. That's great. And we have 3 and 9 here. But again, this u-sub just converted this x integral into a u integral. Notice that this integral, again, is the exact same thing as the given. The integral from 3 to 9 of f of something d something is going to be the same no matter what the something is, because the constant of integration, you're just labeling the axis in a different way. But instead of originally knowing that this is equal to 5, I want to find all of this, because this integral by the u-sub is equal to this quantity. I know just the simpler integral, so instead of setting this equal to a number like we did in the previous case, we're just going to take this 5 and replace it. So in this case, the answer is going to be 1/2 times 5, which is 5/2. So notice the subtle difference between this question. In both questions, we started off with the u-subbable one, but in this one, the u-sub was the given one, and we wanted to find the simpler one. So because we performed the u-sub on the u-subbable one, we had an equation that involved that. So when we converted it to the easier one, we had an equation involving the easier one. In this one, we started off with the u-subbable one, we did the u-sub process, and we didn't have an equation because we're starting off with the one we want to find. So what we did is we replaced the simpler one, which was the given, where it needed to go, and that's all it is. So again, basically the thing is you have this relationship between this thing, and sometimes the givens are different, but you're always going to have a pretty simple equation where you either plug it in, where you set it equal based off the givens, but hopefully it makes a little bit of sense that once you perform the U-sub process, it should be very clear of which one you want to do. Do I want to start off with the harder one, meaning that I'm going to set up an equation once I do the U-sub, or am I have this case where the harder one is the U-subbable one? That's the one we have the question about, where after I do the U-sub, I just plug in the simple one and I don't form an equation. So hopefully that makes sense. Let me do one more question that's a little bit harder, just to see if we have sort of a slight grasp on this. I know this is difficult, but if you practice these enough, if you just start making up these questions, then you should be good to go. But let's do a harder one. One more for the road. Why don't we? So I'm going to do the integral of f of square root of x, and we want to find this integral. This is going to be, let's say 4 and 9 here, times dx. And there's going to be a given where the f integral of just f of x dx of, I believe we want 2 and 3, this number is -7. So again, we use this given to try to find this one. So it looks like this one is going to be where the harder one is given, the harder one is the question. So let's just go for this question. So again, what you want to do is you want to just do a U-sub. This is one of the harder U-subs where it will be a lot nicer if we write it as powers, because we want to perform the power rule. So I'm going to write it as x to the 1/2. And because I've done this question enough, it's actually beneficial to write this as x to the -1/2, the denominator, as you will see, so that when we sub in, it will be a little bit easier. So let's get going. What should the u be? Well, the u, I argue, is going to be x to the 1/2. That's inside another function of f. Also, its derivative is 1/2 x to the -1/2, which is basically this. So that's why this question, this is a good choice for u. So it's going to be u is equal to x to the 1/2. Then du is equal to be 1/2 x to the -1/2. So times dx, of course. So now we're ready to change all of our x's to u's. So it's going to be an integral. Looks like we chose this u so that the u gets placed right here. So it's f of u. Then we have all of this stuff, but it looks like we're doing the question correctly because x to the -1/2 dx is in this line. We're going to isolate it just like normal. Because this constant is already a fraction, we're going to bring it to the other side. So in this case, we have the rare case where you don't have a fraction actually, but we're not going to complain about that. So that's going to be 2 here. Then we're going to, of course, change the numbers. The numbers shouldn't be too bad because it's just square roots of these perfect squares. So when x is equal to 4, that means u is equal to 2. The square root of 4 is 2. Same thing with 9. The square root of 9 is 3, which are perfectly these numbers right here. So it's going to be 2 and 3. So now all we have to think about is how do we incorporate this number -7? Do we want to set this to be equal to -7 so that the answer will be -7 divided by 2 to isolate this? Or do we want to plug in -7? Well, just keep in mind that this is the question. The question got converted to this after the U-sub, so I want to find this entire thing. I don't want to separate the 2 and the integral because I need to find all of this because this is all equivalent to this. So I'm going to use this given. If I can write the word given one more time. Given. So I'm going to use this given. I'm going to plug in this time. I'm not going to set it equal. So when I plug this in, -7, looks like I'm going to get 2 times -7. That's -14, and we are done. So these are the harder general U-sub questions. You really want to focus on the table questions, which I believe are a little bit easier, and these weird multiple choice questions where you do a U-sub and then you use a given integral to finish the question off, whether that be plugging in like this case, or if this were the given and this was the one, we would probably set up an equation and the answer would be -7/2. If you want more practice of this, of course, we have another Girls Teach Calculus video in the description below that I alluded to before. What we do in that video is we go over several of these questions. A former student of mine, she has a few table questions. She has those weird multiple choice questions that we talked about in the very beginning that are actually pretty easy. And then on the back page of that worksheet, she just does a ton of these sort of questions just so that you can have enough practice with these. So be sure to check that out if you want more practice with these questions because they're pretty difficult and my students do mess them up a lot. they'll see this integral and they'll like see, oh, the answer will be -7/2, or the answer will be -7 times 2, and they don't know which one is which. So that's that. Just keep in mind that, again, you really just want to know the U-sub process. These integrals aren't as common as our just normal integral of sine of 3x or something like that. As you're doing the U-sub process, just change all your x's to u's using that two-step process. If there's numbers on top of the integral, you need to change the numbers, just make that step. Finally, once you're ready to take the antiderivative, you should only have u's, then you take the antiderivative, and then perform fundamental theorem of calculus, top minus bottom. Hopefully this was useful for you. If you want more practice and if you want a recap of the previous 4 videos, check out our next calculus done wrong lesson, where we're going to just review AB integrals. So these are basic integrals that don't require U-subs, like split the numerator. Those are going to be our indefinite U-subs, our definite U-subs, and also our general U-subs. So hopefully I will see you then. Hopefully this was a little bit useful for you and that you were able to benefit from it. I hope to see you in that AB integral review. Thanks again for watching, just like normal, and I hope to see you next time.